This is going to be a bit of a bigger section, but that's because we're talking about all of the basic rules of algebra. These properties are really important because they are the basic properties that we need. So first off, we have the commutative property of addition. Commutative says that you can basically swap the order and it doesn't matter. So A plus B equals B plus A always. We also have this property for multiplication, which says AB equals BA. Okay? Now, as far as examples of this go, for instance, 4x plus x squared is the same thing as x squared plus 4x. And 4 minus x, which is all treated as one expression, times x squared, is the same thing as x squared times 4 minus x. Now, the associative property of addition and multiplication, associative properties say that if you want to add, for instance, 3 numbers, it turns out it doesn't matter whether you add these 2 first or these 2 first, because we always know based on order of operations, parentheses happen before anything else. And so essentially this says that if you add 3 numbers up, it doesn't matter what order you add them in. For example, we could write x plus 5 plus x squared, or we could write x plus 5 plus x squared. The associative property of multiplication is very similar. It says if we do a multiplication with a and b first, then multiply by c, it's the same thing as taking the multiplication of b and c first and then multiplying by a. For example, we could write 2x times 3y times 8. Or we could also that would be the same thing as saying 2x times 3y times 8. Distributive properties are very important as they're the only properties that show how addition and multiplication interact with each other. This is where we get the idea of distributing, namely you distribute the a to the b and to the c. And similarly, it distributes on the other side as well. So the distributive property works on the other side as well. AC plus BC. For example, we have that 3x times 5 plus 2x. That would be the same thing as saying 3x times 5 plus 3x times 2x, where again it's assumed that the multiplication happens before the addition based on order of operations. The additive identity property says that if you take any number and add 0 to it, it gives you a. Because of this, 0 is called the additive identity. For example, I could take 5y squared and add 0 to it, and I would still have 5y squared. Note also that 0 plus a still equals a because of the commutative property of addition. Now, we also have a multiplicative identity as well, namely if we have a times 1, that always gives us a back. Which is to say that if we had, for instance, 5y squared, why not use the same 1 times 1, it would be 5y squared. Now, the additive inverse property says that we can always find a negative of a such that when we add it, we get back to our additive identity. This is called the additive inverse of a. So for example, 5x cubed, the additive inverse of that would just be slap a negative on the front, so 5x cubed, which equals 0. Multiplicative inverse property says that if we take a number and we multiply by its reciprocal, 1 over a, then that always gets us back to 1. Namely, here, this is called the multiplicative identity. Hopefully that's not too hard, that's not too small to read. Of A. That is, if we had, you could do this with all sorts of things. So if I had x squared plus 4 and I multiply by 1 over x squared plus 4, I would get 1. Okay? So these work with all algebraic expressions. Now, for example, if we were to go through here, and it's very important to be familiar with this terminology of those properties. So let's go through and look at what of the rules of algebra are illustrated by these statements. For the first one, we see that this is saying that we can multiply this way or we can swap the order. That would be commutative. Because it's a multiplication, it's the commutative property of multiplication. Also, we see with this one, we're taking 4x plus 3 and subtracting off the same number. That's the same as adding the negative. We'll talk about that in a moment. Which gives us 0 back. That would be the additive identity property. For C, we have that 7x times 1 over 7x. We're multiplying by the reciprocal. That looks like the additive, oh, sorry. This would be the additive inverse property. So let's backtrack that. So we see here that 4x plus 3 minus 4x plus 3 equals 0. That would be that we're really adding the negative. That is, we're adding its inverse. So that's the additive inverse property. So that's the additive inverse property. Here we see that we're taking 7x, multiplying by its reciprocal, 1 over 7x, to get back to 1, assuming x is not 0, which is to say that we're really multiplying by its multiplicative inverse, and so this would be the multiplicative inverse property. So D, for D, we see that 2 plus 5x squared plus x squared, we're interchanging what order we do when we do the additions, thus we're associating it, and so this would be the associative property of addition. So now let's have you try an example. Go ahead and identify which property is at work in this example. If you would like to check yourself, here's the answer. It's the distributive property. Now, we further define subtraction, as you saw in the last example, as adding the additive inverse. We also define division as multiplying by the multiplicative inverse, which we can also write as A divided by B. Now, subtraction and division are not commutative, and it's important to note this. For example, 7 minus 3 you can see is not 3 minus 7. The answer will be off by a negative because this is 4 and that's negative 4. And we also can see that 20 divided by 4 is 5, whereas 4 divided by 20 is 1/5. They're also not associative either. Namely, if you were to do this subtraction in this order, you would have 5 minus 1, which is 4. But if you were to do the subtraction with this subtraction first, you would end up with 5 minus 3, which is 2. 2 minus 2 is 0, and 4 and 0 are not equal to each other. In a similar way, 16 divided by 4 divided by 2 will not equal 16 divided by 4 divided by 2, where we do this division first. This side would be 16 divided by 2, which is 8. This side would be 4 divided by 2, which is 2. All right, moving along, we also have several properties of negatives and the equal sign. So to start with, we're going to go ahead and let A, B, and C be real numbers, variables, or algebraic expressions. It doesn't matter what they are. All these properties still work. The first property we have is that negative 1 times A can be thought of as just negative A. An example of that is that negative 1 times 7 is just negative 7. We also have that a negative times a negative equals A is just itself. So we also have that a negative times a negative is a positive. And for example, negative times negative 6 is 6. We also have this property, so you can move around negatives a lot through multiplication, which is to say that negative 5, for example, negative 5 times 3 is negative 5 times 3, or you could even write it as 5 times negative 3. Another example is if you do a negative number times a negative number, it's just the same as multiplying their positive numbers. For instance, if you do negative 2 times negative x, that's the same thing as just 2x. Negative a plus b is negative a plus negative b. So for example, negative x plus 8 would be the same thing as negative x minus 8. Basically distributing the negative. Now, all of these properties, let's take a break and talk about this a bit. All of these properties have, we've used them quite a bit, and we've actually, they're actually probably very familiar to you, but it's still good to go ahead and write them down, and please be very aware of them. The next set of properties are going to be have to do with equality, and they'll be very helpful for us when we start to solve equations. So, for instance, if A equals B, then we can say A plus or minus B is the same thing as, then we can say that A plus or minus C is the same thing as B plus or minus C. And similarly, if A is equal to B, then we can say that AC is equal to BC. On the flip side, if AC, if A plus or minus B, if A plus or minus B equals B plus or minus C, on the other hand, if A plus or minus C equals B plus or minus C, we can cancel the C's off and get that A equals B. For multiplication, you have to be a little bit careful, namely if AC equals BC and C does not equal 0, then we can go ahead and conclude that A equals B. For time, I'm just going to skip examples. We'll see a lot more of that later on with solving equations. 0 also has several important properties. The first property of 0 is that a plus 0 equals a, and a minus 0 equals a, as we've seen already. We also know that a times 0, a number times 0 is always 0. And we also know that 0 over a, any number divided by, 0 divided by any number is always 0, assuming a does not equal 0. And then finally, we have that a divided by 0 is undefined. A few notes. The first, before moving on, because 0 times a number is 0, and we defined we define division as multiplication by an additive inverse, this is why we're not allowed to divide by 0, because 0 does not have a multiplicative inverse, because if it did, then 0 times it would give you back 1, and we know that no such number exists. We finally have the zero factor property, which says that if AB equals 0, then A equals 0 or B equals 0. And as I note here, that last property is very important for factoring later on, because that's how we solve equations using factoring. All right, and finally, we come to properties and operations of fractions. Please pay very special attention to this, as I know many of you probably struggle with fractions. So, as far as equivalent fractions go, we say A divided by B is C divided by D, if and only if A times D equals B times C. The way you usually think about this is called cross multiplying, right? You multiply top and bottom by B here. You go ahead and you cross multiply. Rules of sign says that if I do negative A, B, that's the same thing as I can put the negative in the top, or I can put the negative in the bottom. And it doesn't matter, they're all the same. Also, we know that if you have a negative in the top, negative in the bottom, they go ahead and they cancel. This is, again, because of how we defined addition, not addition. This is, again, because of how we define division, which is as a multiplication. We know that multiplying two negative numbers cancels out the negatives. General equivalent fractions. The generic equivalent fractions is that A divided by B. You can go ahead and put any number in the top and the bottom, as long as that number is not 0. We can also add and subtract with like denominators pretty easily. Namely, if you have the same denominators, you can just write A plus C all over B. On the other hand, we also see that if we don't have like denominators, we have to get a common denominator to add and subtract. So A plus or minus B, there was also a plus or minus up here. A plus or minus B, A over B plus or minus C over D. We have to get a common denominator first. To get the common denominator, we go ahead and we multiply top and bottom by D here and top and bottom by B here. So we have AD over BD plus or minus BC over BD. Now that they have a common denominator, we can go ahead and combine them. So we get AD plus or minus BC over BD. Multiplying fractions, on the other hand, is much easier. If you have A over B times C over D, you just multiply the top and multiply the bottom. Finally, to divide fractions, the best way to divide fractions is to think of it as a multiplication by the reciprocal. So A over B divided by C over D is the same thing as multiplying by taking A over B and multiplying it by the reciprocal, which is D over C. That is, using the last property, it would be AD over BC. Again, to the uncomfortable student with fractions, if you learn these, I claim you will have fractions mastered in no time. So let's do some examples to show this. If we want to simplify 3x over 15, we can notice that there's that 3x over 15 is the same thing as 3 times x over 3 times 5. The 3's then cancel using property 3 of the last page, and so we end up with x over 5. If we want to divide these two fractions, we can write this as 7 over x divided by 3 halves. We know that's the same thing as 7 over x times 2 over 3. But then that is just 14 over 3x. So now again, it's time for you to try. I really want you to do this example because you probably have trouble with fractions. Here are the answers. So, also, you may want to remember to simplify. So here are the answers if you're ready for them. Here it's x over 10 when multiplying these, and here it is x over 2. Here, please remember to get a common denominator and add them together, and then simplifying is very key for both of them. Okay. We're almost done. A few extra helpful things. If a, b, and c are integers such that a times b is equal to c, then we say a and b are factors, or sometimes we call them divisors of c. So, for example, 6 equals 2 times 3. So 2 and 3 are factors of 6, or 2 and 3 are divisors of 6. We also say that a number is a prime number if it's an integer that has exactly 2 positive factors, itself and 1. Namely, for example, we have 2 as a prime number, 3 is a prime number. 4 is not a prime number because it's divisible by it has 2 factors. 2 and 1 are actually both factors, so 2 and 2 divide it. 5 is prime, 7 is prime, 6 is not prime as we showed. 8 is not prime because of all the 2's. 9 is not prime because of the 3's. 10 is not prime because of 2 and 5. 11 is prime, and then 13 and 17, and there's a bunch more. We then say a composite number is sort of the opposite of a prime number. So a composite number is an integer that can be written as a product of 2 or more different prime numbers. So the composite numbers start with 4, 6, 8, 9, 10, 12, 14, etc. One important thing to note about this is that 1 is neither prime nor composite, and 0 and negatives don't really count in this classification either. So you really need a number to be greater than an integer greater than 1 to classify it as prime or composite. As far as a memorization alert goes, you need to know all the properties I talked about before and be very comfortable with using them. Otherwise, algebra is going to become very difficult for you. For more practice in working with real numbers, be sure to look at page A12 of the textbook. And in our next video, we'll be moving sections and talking about integer exponents and their properties.